Hi, welcome to the third video review of this thing. Okay, we are on part E of question 9. We're trying to find asymptotes. Let's zoom in here. Okay, the first thing to notice is looking at the vertical asymptote idea. We want to know where the denominator is 0, but only if it doesn't cancel with the numerator. This guy cancels with the numerator, so it does not have a vertical asymptote. Horizontal asymptote would require the top and bottom to have the same degree, but they don't, because if we were to multiply out the top, we would get x squared minus x minus 2 over x plus 1, and that's a different degree, so there's no horizontal. For the slant, the degree is higher by 1, so we do have a slant asymptote. This is where we would normally divide x squared minus x minus 2 divided by x plus 1, but it was already given to us in a factored form, so actually we already know this is x minus 2. So our slant asymptote is going to be y equals x minus 2. Okay, part F. There's no horizontal because this is degree 0 and this is degree 1. For the same reason, there's no slant. And the vertical asymptote is going to happen when the denominator is 0. So if I solve that, I get x equals 9. Next page. Part G. Okay, as before, the degree of this is 0. This guy is degree 2. That tells me I have no horizontal asymptote and no slant asymptote. For the vertical one, I would need x squared plus 2 equal to 0. But x squared is always positive. 2 is, or at least non-negative. 2 is always positive, so that's not ever going to happen. Because this thing has no solutions. Okay, problem 10. Find the absolute maximum and minimum values of the function f of x equals x cubed minus 2x squared minus 15x plus 5 over the interval negative 2, 0. It's a closed interval, so we're going to first find the critical values. We've got f prime of x equals 3x squared minus 4x minus 15. This factors into 3x plus 5 times x minus 3. So to set that equal to 0, we get 3x plus 5 times x minus 3 is equal to 0. That tells me 3x plus 5 is equal to 0, or x minus 3 equals 0. Over here, a little bit of elementary algebra gets me x is negative 5/3, and over here I get x is equal to 3. So those are my possible critical values. So now I want to, I guess I'll number these so they're in order. Now I want to look at them on the interval negative 2, 0. So here's what I need to check. I need to check negative 2. I need to check, because that's the end point. I need to check negative 5/3, because that's a critical value. 0 is an end point. I don't need to check 3, because it's not in my interval. So when I plug these in, I get f of negative 2 is 19. F of negative 5/3 is 535 divided by 27, which is about 19.81. And f of 0 is 5. So I'm just looking at these to see which is the biggest and which is the smallest. This is the min. and this is the max. So my absolute maximum value is 535/27, and it happens at x equals -5/3. And my absolute minimum value is 5, and that happens at x equals 0. Okay, now number 11. Find the absolute minimum and or maximum and or minimum values of this function, if they exist. Okay. It's not telling me on what interval, so I'm going to assume it means on the entire real line. So I can only solve this problem if I find there's only one critical value. So f of x, I'm going to go ahead and multiply it out. I get 14x minus x squared. So my derivative, f prime of x, is 14 minus 2x. When I solve this equal to 0, I get x is 7. So I have exactly 1, so I know that that's an absolute max or an absolute min. I just have to figure out which one. But if we look at this, this is a parabola opening downward, so it's a max. And now I need to find out what the max is here. Here is. So f of 7 is 7 times 14 minus 7. That's 49. So I know I have a max, absolute max, of 49 at x equals 7. Okay, word problem. Of all the numbers whose sum is 42, find the two that have the maximum product. Alright, so I've got numbers x, y, such that x plus y equals 42. Here's what I want to maximize. I'll call it product. X times y. Now I'm going to write this as a function of one variable. So I'm going to write it as x times 42 minus x. That's just solving this guy for y in terms of x. Okay? So this is the same as 42x minus x squared. So my first derivative is 42 minus 2x. When I set that equal to 0, I get x equals 21. I know it's a max because this function is a parabola opening downward. And I know that means y has to also be 21 since they add up to 42. And it wants my answer in the form of a sentence. So here goes. Of all numbers whose sum is 42, 21 and 21 have the highest product. Okay. This next problem is about an apple farm. It's another maximization problem. What we want to know is how many trees should be planted on an acre, so I'm going to identify that variable first. I'm going to say T is trees per acre. What happens is when I plant more trees, I have less yield. So I'm going to let y equal yield per tree. And what I want to maximize is my total yield. So I'm going to let T be my total yield. and it's pretty obvious that T is the trees per acre times the yield per tree. I shouldn't say it's obvious, but it's true. Okay, so now the trick is getting Y in terms of T. Okay. So it starts off by telling me this. I get 36 bushels of apples per tree as sort of my baseline. That's when 22 are planted. And for each one above 22, I get one less. So I'm going to subtract the number I did minus 22. So now when I go over 22 by 1, I'm subtracting 1. If I go over 22 by 2, I'm subtracting 2. So that's perfect. So I can rewrite that distributing the minus sign as 58 minus T. This makes my yield function now be Ty, which is now T times 58 minus T, or 58T minus T squared. Now I want to maximize this, so I want to take my derivative. T prime of little t is 58 minus 2t, and now I'm solving that. 58 minus 2t is equal to 0. That gives me 2t is equal to 58, which gives me t is equal to 58, which gives me t is equal to 29. I know that this shape of this function is a downward opening parabola, so I know this is a max. So here's my answer in the form of a sentence. We receive the maximum yield per acre by planting 29 trees per acre.